Assalamualaikum. It's 17TE68 and today we are going to study lecture number 2 of DHP, which is about signals and system. Signal is the description how one parameter varies with another variable, and system is the process that produces an output in response to any input. Some examples are averaging system. Averaging system is the system that takes the average of all the signals, like there are five signals and we are taking the average of it. Moving average system is when the system moves from one point to the next and then we take the average of it. Flip system, when we shift the system from left right to left and left to right, then we flip the system. Next is shift system. Here's the example: y of n equals to x of n plus 1. Here for n plus 1 we will shift our system one step behind. Original signal was x of n, and now that is shifted one step behind, and for this signal x of n minus 1 we would shift our system one step ahead and we will get this system. Index scaling is y of n equals to x of 2n. You must be dividing your sample by 2. 2 divided by 1 is 1, so we'll be getting this result. Y of n equals to x of n by 2 means you must be multiplying your signal by 2. 2 into 2 is 4. So original signal was that x of n, this x of n, we are applying all that operations on this signal and we are getting the results this. Next example is y of n equals to x of minus 2n plus 1. We will apply the principle FSS. F stands for flip, S for shift, and S for scale. And we must first flip the system, then shift, and then scale the system. Let's take another signal x of n. Here we have this signal x of n, and for x of 3n, means 6 divided by 3. 6 by 3 is 2, so we will be getting our signal this. If we apply y of n by 3 on this signal, 3 into 2 is 6, we'd be getting this signal. So comparing this with the original signal, we have lost these samples, so we are so we will just apply certain techniques to recover back these signals. First technique is zero order hold. For zero order hold, we have to take one sample like this, then take the replica of the previous sample, two replicas of the previous sample like this, join the peaks and measure the accuracy, check the error. Like this is the obtained signal and original signal was this, so it's not the accurate technique. Moving on to next is first order hold. First order hold, you have to take two samples like this and this point. We will use slopes to determine the midpoint, and we are drawing this sample. Comparing it to the original signal, accuracy is improved but not that much. Second order hold. So moving on to next technique, which is second order hold. Here we have to take three samples, then find the second order derivative. Like these are the 3 points, x0, x1 and x2. We are calculating the difference of the values like this, and we are calculating again the difference of these two values and we are getting this result. This technique gives curves instead of lines, so it is not much accurate technique. Accuracy is improved but not that much. Moving on to next technique, which is drawing sinc function at all peaks. These were the peaks and we are drawing sinc function at all the peaks. So comparing this with the original signal, accuracy is improved. From other techniques, accuracy is improved. Next, we have unit impulse. um, Unit impulse is 1 at n equals to 0 and 0 otherwise. Unit step is 1 for n greater than or equal to 0 and 0 otherwise. Relationship between the two is impulse function is the derivative of step function, and step function is the integration of impulse function. Now we will study signal synthesis and decomposition. Here is the signal, and we are decomposing signal with impulse. Like this was the signal. This has 3 samples, and we have drawn it separately. So for convolution, this is the formula. This is the original signal, and this is the impulse response of it, and we are convolving it. Next we have signal decomposition via step. In this, we decompose n sampled signal each into a unit step signal. Whatever we have the samples, we will be converting them into step signal. Even next technique is even odd decomposition. We have divided our signal into even and odd samples using these formulas. In even symmetry, signal is symmetrical about the origin, but in odd symmetry, samples have the equal magnitudes about the origin, but they are opposite in sign. Thank you so much. That was all about signals and system.